top, which I didn't really need, but I've got one. So here we go. Example 3. Find the GCF, the greatest common factor, that goes into 882 and 945. Okay, guys, and this is the way we're going to do this. Greatest common factor. A factor is a number that goes into these, right? So is it going to be smaller or larger? It's going to be smaller because it's got to fit into them, okay? So here's what we do. We're going to take 882 and 945, and we want their prime factorization. Okay. Let's see. 2 times 441. All right. Now 2's prime, but who knows what goes into 441? Yeah. What? 147. Say again. 147 times 3. Yeah. Okay. All right. Let's go with that. 3 times 147. Okay. What about 147? What goes into 147? Gordy. 3. Another 3 goes into it. 3 times what? 49. And then that's 7 times 7. Okay. So for 882, the prime factorization is 2 times 3 times 3 times 7 times 7. Okay. For 945, I'm just going to draw a little line here. I could scoot 945 over so we're not so cramped. 945. Okay. I know 5's going to go into it. Don't tell me. Let me just see if I can, how long it takes me. 189? Is that right? Okay. I think 9 goes into that 21 times. 3 and 63 would work too. Sure. It doesn't matter. We're always going to come down to the same numbers. Okay. This is 3 times 3. And then this is 3 times 7. So I'm going to get 5. I'm sorry. Remember, least to greatest. 3 times 3 times 3 times 5 times 7. For greatest common factor, we pull out all the factors that they have in common. Okay? Do they both have a 2? No, so I can't use a 2. Do they both have a 3? Yes. So they've got this 3 and they've got that 3. So I know the greatest common factor will have a 3 in it. Okay? Do they both have another 3? Okay? So I know I can put another 3 down here and they'll get multiplied in the end. Okay? Do they both have a 7? Yes. They both have a 7. Okay? Is there anything else that they both have in common? No. That's it. So the greatest common factor, that means the biggest number that goes into both of them, is 63. Okay? That's it. Done. Now we will use that with variables as well. It'll be the same process, but I'll have xx and xy over here. And I would say, oh, look, they both have an x. So I could put that down there too. Okay, now they don't in this one. I'm just saying we're using this process even when we have variable expressions. All right, yeah, Devin. I mean the greatest common factor, yes, that we're looking for, its prime factorization is made up of the common factors, the common prime factors of these two numbers. And then I just multiply them together at the end. Okay? Yeah, Troy. You could list all of the factors, but that gets long. That gets very long. Okay? Yeah, and especially too once you get variables in there, you know, with all the factors. So, okay, good job, guys. Let's look at this next example.